So the trig ratios, trig, all to do with a right angle triangle. Well, that's where we start off looking at trig anyway. And we name the sides. We know the largest side's the hypotenuse. And then depending on which angle we're referring to, so let's assume I'm referring to the top one there, then the opposite side very cleverly is called opposite. And the one next to it, very cleverly, is called adjacent. Adjacent, of course, meaning next to. And there's our three basic trig ratios that we start off with. Opposite over hypotenuse is sine, adjacent over hypotenuse cosine, opposite over adjacent is tangent. The reciprocal ratios, and I mentioned this, it was just yesterday, wasn't it, when we looked at inverse functions. We have those because we don't write the trig ratios to a negative power. It's not normal to see that. So, and I think they were very mean. I don't know about you, but I reckon they were mean. Because to me, the upside down of sine should be sec. Why would you make it cosec and then the upside down of cosine is just sec? That's just mean, but that's what they did. Okay, so cosec is the reciprocal of sine and sec's the reciprocal of cosine, and cotangent is the reciprocal of the tangent ratio. Why? Where does co come from? Co itself is an abbreviation as well. It's an abbreviation for the word complements. So they are known as complementary ratios because the sine of theta should always be the same as the cosine of 90 minus theta. The two angles are complementary. They add up to be 90 degrees. So if I see something like this, sine x is equal to cos 25, well, I know the two angles should add up to give 90, so x will be 90 minus 25, x is 65. So if I have one with algebra, I can still use that same idea. Well, I know cotan and tan are complementary ratios, therefore those two angles should add up to give 90, and we get x is 40. Oh, wow, I said we're going back to the basics. Here we go. How do we find A? Well, we have to work out which ratio we want. So we identify the sides. We have opposite over adjacent, which is, of course, the tan ratio. A then is 13 tan 61. You punch the buttons on your calculator. I've done it to one decimal place, 23.5. Of course, the other situation we might get is where we can't place the pronumeral on the top of the fraction, unless I use the reciprocal ratios. However, whilst I could have put x over 5 as the cosecant of 32 degrees, I certainly could have done that. Wouldn't have really helped me because we don't have a cosecant button on the calculator. So I really need to stick with sine, cosine and tan. So 5 over x. When I first started doing trig, when did we first do that? Year 8, year 9? Something like that, isn't it? How I always used to just remember it is if the pronumeral's in the top of the fraction, then I multiply. But if the pronumeral's in the bottom of the fraction, I divide by the trig. That's how I always remembered it. So x is 5 divided by sine 32, 9.4. That leaves one other situation we could have, and that is if we had to find the angle. So cosine of theta is 10 on 14. That's what I was talking about with the negative 1. That does not mean to the power of negative 1. It's talking about the inverse cosine. On your calculators, you'll see that above the cosine button, it's written there, cos negative 1. It's how you find the angle. So the inverse cosine of 10 on 14 turns out to be 44 degrees, 25 minutes. I've done it to the nearest minute there. There are some ratios we should just know. We should not have to go to the calculator for. How do we get them? The first one starts off with this lovely triangle, which happens to be an equilateral triangle, sides all being 2. If the sides are all 2 and it's equilateral, that means all the angles are equal and equal to 60 degrees. So if I chop it in half, I get the lovely 30-60 triangle. The base I've chopped in half, so it's 1. Bit of Pythagoras. I get the square root of 3. Now I can just read off the triangle all those exact ratios. Sine 30 equals a half. Cos 30 equals root 3 on 2, or for those who are obsessed and going to their calculator and unsure, you'll find that's about 0.8660. Tan 30 is 1 on root 3. Oh, that one's about, I always get these ones mixed up. 0.57. Then we do sine and cosine and tan, and we notice what I was just talking about. Look at that. Sine of 30, same as cos of 60. 30 and 60 add up to 90. Oh, look, cos of 30, same as sine 60. 30 and 60 add up to 90. Now, how do we find the other one, 45 degrees? Well, now I have an isosceles right-angled triangle, which means both of those angles are 45. I'll make the two sides there equal to 1. By Pythagoras, we get root 2. And so we can read off that one. Sine 45 is 1 on root 2, which is about 0.707. Hey, here's another way, by the way. I don't know if you've ever seen this. Watch this. This is really cool. There's a table of values here. Sine, cosine, and tan. 0, 30, 45, 60, 90. Look at that. There's your ratios. Square root of 0 on 2, square root of 1 on 2, square root of 2 on 2, square root of 3 on 2, square root of 4 on 2. How cool is that? Cosine then goes the other way. Now, tan, well, tan is sine divided by cosine. The denominators are the same, so just root 0 on root 4, root 1 on root 3, root 2 on root 2, root 3 on root 1. Yeah. There you go. Oh, I think it's a lovely pattern, which not often we show, so here I am showing it to you. Isn't it a lovely pattern? Measuring angles then. So we get those, those trig problems that we used to getting, those sort of real world situations. And they talk about things like angle of elevation. It is exactly what the name suggests. It's the angle that you elevate. So you lift. So that angle there would be the angle of elevation of B from A. So it's always from where the angle is. That's the reference point. So of what you're looking at from where you are. Then you have angle of depression. So depress is to lower. So similar thing. The angle there, I've got it Y. So that would be the angle of depression of X from Y. X is what I'm looking at. Y is where I am. Now, in a problem, the interesting thing is the angle of elevation in one situation will always be equal to the angle of depression in the other situation because you've got alternate angles, parallel lines. Then there were these things, compass bearings. Of course, we start off with the 4 basic ones, north, east, west and south, which of course creates the word news, and that's why we call it the news, because it's the information from all around the compass. I don't actually know if that's true, by the way, but I think that's not a bad way of it. Then we can subdivide each of those. You start with the vertical ones and always go to the horizontal. So we have northeast, northwest, southwest and southeast. Okay. You can keep dividing, but again, always start at the more important one, if you like. So the blue ones are the more important because they came first. So you start at the blue, go to the red. So the one at the top there, north, northeast, then east, northeast, east, southeast, south, southeast, south, southwest, west, southwest, west, northwest, north, northwest. And of course you could keep going like that. So if I was to divide in half between northeast and east, northeast, I would start at the more important one where the red came first, then the green. So I'd start with the red, and halfway in between would be northeast, east, northeast. But of course now it's starting to get ridiculous, and that's why we came up with true bearings, and we just say this is how many degrees you go. Okay, so with true bearings you always start at north and say how far around have I turned in a clockwise direction. So there's X and Y. We would say the bearing of Y from X. Now, if you've got that situation, that means the compass must be located at X, because it's from X. And so we know that angle's 30 degrees. Then our bearing would be 120 degrees. Some people put a T there to say it's a true bearing, but the bearing is 120 degrees. Or, of course, you could use your compass bearings and say it's south, that would be the more important one, and we've gone 60 degrees towards the east. That'll be another way you could call that one. If I was to go the other way then, what's the bearing of X from Y? Now I'll put a compass at Y, bit of geometry, I can work out that angle's 60 degrees, and so we're at 300 degrees in the true bearing. Or, north, 60 west. The thing to remember with bearings is it's always 3 digits. So if you've only gone, say, 20 degrees, then it would be 020 degrees. 6A, you'll notice 2 to 5 I've said just pick some. Because I think it's just calculate. Can you use your calculator? Well, you work out whether you can use your calculator. Just pick something to do and make sure you can handle it on the calculator there.